Okay, so let's start. Next session is indeed about how to deliver a functional API design based on more than a gut feeling. And the reason why I've put this title for this presentation is because of the fact that I've been working in integration or in consultancy the last 10 years and 8 years in integration. I've always been a more functional oriented guy. And to be honest, in the first 4 to 6 years, when I really was an integration analyst, I never really could defend the way I created my services as SOAP services or REST APIs, as in we had little to no information or guidelines on how to actually design an API that is, from a functional perspective, of sufficient quality. And now that I'm working as an architect in the last couple of years, and of which 2.5 years at Belfius, and my job now is to also support the people, the functional analysts in the different project teams to really deliver, from a conceptual point of view, APIs that are aligned with the corporate data model and are really business focused. We needed to start with defining guidelines on how to design these APIs in a functional, correct way. If we take a look at API design and its place within the API delivery lifecycle, we can see it's a very central place. It's at the beginning of the complete cycle, but on the other hand, we have a lot of loops, feedback loops, and the API design part is a real important part in the whole process. Especially when we go contract first, we need a proper design to be able to allow our API consumers to already test it, the virtualization of the API, the build, etc. It all depends on the API that is designed in the API design phase. Now, the delivery lifecycle itself, it's a very clear process, and within the market, there's a lot of different tools to support this process, specifically concerning the design. We have, for example, Swagger for our standard REST APIs. We have Async API as a tool to create APIs for event-driven architectures. We also have a lot of websites and parties who expose their design guidelines online, and a lot of parties who actually create blogs or write blogs concerning how to design a proper API. But the focus of all these things are really on the technical contract. They never mention how to define what the correct size of a resource is. Or what the correct size of the API domain is, which entities should be part of the domain, which ones are outside of the domain, and thus, from a functional point of view, we are a bit kept in the dark based on guidelines and toolings from an integration point of view to really define the correct scope of our API domain and the scope of our resources. And if you want to go towards a real good API design from a functional point of view, it actually starts with the business capability map, or even more with really taking into account what kind of business value that you want to deliver, what kind of business domains that are owner of a specific functionality, and therefore that they really start considering these APIs as their own, and not just something that IT has provided to enable them integrate with other applications or other parties. So the business capability map is actually the first start to really properly design a functional API. And when we started with the definition of the corporate data model, and this is a slide, or this is a picture that you also saw in the PowerPoint of Wouter. We, when designing the corporate data model, have defined that this corporate data model actually has 5 different levels. And from enterprise architect point of view and corporate data office point of view, we were responsible for delivering the first 3 levels: business capabilities, the information domains, and the subject areas. Now, the business capabilities themselves, this takes a while to create them. They're not always as easy to define as we wish it would be. So in my opinion, the least that we really need to do is define which kind of information domains are relevant within our context, and even more important, what kind of subject areas are all mapped or all part of an information domain. This level, or the definition of what is a subject area and what is an information domain, I will give an example later on, but the most important part is actually that we arrive at a level, a level that we called subject area in this exercise, or the definition of the corporate data model at Belfius, where we really get to a level where the ownership of a specific area is is good defined and unambiguous. So we need one business owner for each subject area who can make decisions on what kind of data is part of this area, what kind of data is outside of this area. So from enterprise point of view, or enterprise architecture point of view, and corporate data office, we started with defining business capabilities, evolving towards the information domains, which are part of the business capabilities, and the subject areas that are part of the information domains. And from the different projects that we have, like our digital enabled banker, our integration, for example, with Proximus, they started to request new data requirements. They identify these data requirements, and they defined what kind of information was necessary to be exposed through our corporate data platform, and thus needed to be modeled in the corporate data model. So the projects came with the different terms, for example, a national registry number, and from enterprise point of view and corporate data point of view, we started with defining, for example, for the party domain, that we evolve from the generic supporting services, of which the party information management is a sub-capability, then the information domain party domain. Next party subject area, which really contains the signalétique data of a specific party. One of the concepts within this domain could be the natural person, and then have it until the level of data terminology, as in a national registry number of a specific natural person will become a data term within the concept of natural person. So taking into account the rest of the presentation, we will really be focusing on one specific subject area, the party subject area, and we will drill down from business capability map to information domain to the subject area, and from there we will go into the approach on how to create a functional API for that specific subject area. So on the left side, you can see the business capability map of Belfius. This is still pretty high level, so it gives you already a bit of direction, guidance on where to position information domains, but in the end, it's still too high level, too difficult to really define ownership of specific terminology. So what we wanted to do is, from the generic supporting services, this business capability, we've drilled down in different information domains. And part of this area were, for example, the party information domain, but also central contract or central agreement management, central product management, etc. Furthermore, when we go into detail for the party subject area, which is indeed a sub domain, or a sub area of the party information domain, we started to define the different concepts that are part of this model. So here you can see, as a party can have different types. It could be a group of people, so no specific, no real legal type of persons, just a group of persons. We could have a natural person, which could also be a natural person with an activity, the eenmanszaak in Dutch. We can have organizations of different kinds, such as associations, like a soccer club, a legal entity like any corporation that we know from in the how do you say it, in the not public area. So yeah, the real legal entities. And as a last, we can have public entities with a specific focus on governmental services and those kind of things. So we need to define what is a party, what kind of types are there, and what is part of this specific domain. So here you can see relations, all types of relations between parties and other parties or functions is part of the subject area. We also have links to address, to picture, to preferences, but these kind of concepts have been defined as part of another subject area. With the biggest reason that ownership of these kind of concepts are not the same as the owners of this kind of area, or due to the fact that there is little cohesion between the concepts. For example, picture, that's more part of the document area. Document, party are completely different concepts. So we have a connection between party and their pictures. However, the picture itself will be outside of the party subject area. So the concepts, we have them defined for this party subject area. We also define the relations between the different concepts, and as last, the boundaries define what is part of the subject area and what is outside of the subject area. The last thing that I didn't explain yet are the stereotypes. And the stereotypes themselves, they actually really helped us to to define whether or not these entities or these concepts are really business entities, have a business value, or are more extra entities. And to make a distinction between what is the value of a specific concept, we actually took into account a number of domain-driven design principles. So in domain-driven design, they make a distinction between business entities, abstract business entities, and value objects. And within value objects, you can also have computed and non-computed ones. And the business entities are actually all those concepts that, from a business point of view, have their own unique identifier. So this means, for example, a payment account has its own unique identifier. It has an IBAN number, and everybody knows that this IBAN is unique within the complete company, or even within a complete, I would like to say the world, but I'm not 100% certain that this is indeed the case. I would think so, but anyhow. So we have strong entities like a payment account, where we really have a unique identifier within the company or within the complete corporate data model. On the other hand, we can also have weak business entities. For example, a payment transaction registered within a payment account. We could imagine that the payment transaction ID is a concatenation of a timestamp and a sequence number, or a date and a sequence number, just to indicate that it's a specific, this is the first or the second or the third transaction for this payment account. So it will be unique within the payment account, but it will not be unique within the whole context of Belfius. The abstract business entities are entities of which multiple types exist. So in previous example, party is an abstract entity because it can be split up or more specified in the natural person, organization, or party group. Organization itself is also an abstract business entity because it can be further defined into an association, a legal entity, or even a public entity. The value objects, these are actually concepts that don't really have a known identifier. They are defined by the attributes that they have. For example, suppose that we have a party who can have different names, like a legal entity who has both a Dutch and or a Flemish and a French name. We will have two, or we will have a concept or a value object name consisting of a couple of attributes defining the name and the characteristics of this kind of value object. However, the moment that the party itself stops to exist within the context of Belfius, this value object will also disappear. Second one, as an example of a computed value object, for example, at Belfius we have age of a party, which is a computed value object because it's calculated and it's the difference between the birth date, which is part of the party entity or the natural person entity, and the current date that, or the current date, and the difference between them, it's computed and stored within this computed value object. The abstract business entities, I've already said that it's to define typology specifically, but there's also a difference between where the unique ID of these entities are managed. So if they're on the highest level, on the abstract level, it means that all subtypes, or there cannot be an overlap of IDs between the subtypes. However, if we have the ID on subtype level, we cannot, for example, provide a service to retrieve all types of parties just by requesting the ID of the party. So one step even more in detail, we evolve from the conceptual model to the logical data model. We start with also adding value objects. We will define association classes between different concepts. So, for example, between the picture, which is actually some sort of a document, and a party can be linked to multiple pictures. A picture can be linked to multiple parties or multiple other concepts. So we need to define association classes and check where they should be managed, in which domain. So for picture, for example, the place where we should define the association class is in the party domain, because we will create the picture in context of the party. The chances are pretty small that we will create first the picture and afterwards try to link it to a party. So it's important to take into account the reason why you actually want to offer some functionalities. Third thing that we need to proceed with is adding attributes and data types. And as a last one, we need to qualify and name the associations. And next to the stereotypes at the business entity and the value objects on concept level, this qualification of associations is one of the most important things that we need to do to be able to really evolve from a logical data model to an API resource model. Concerning the qualification of associations, we have three types: the inheritance, the composition, and the aggregation. So inheritance is really the type and subtype link. So for example, to define that a bird is a type of an animal. The composition will always define that something is part of something else. This relation will be used most of the time in context of between the links between a business entity and a value object. And for example, a bird and a wing is an example of this kind of composition relation. An aggregation, they are a bit more soft than a composition. However, it indicates the reading direction, or it indicates which part plays the biggest role. For example, that has a relationship, the bird will have an egg. The other way around, it would make less sense. So it means that we have an aggregation between bird and egg. The moment that we have
Johan, sorry to interrupt you, but time is ticking, so you have a couple of minutes remaining.
All right, so I will make some haste. Okay, so this means we have our logical or conceptual data or logical data model, I'm sorry, and to evolve towards a resource model, we actually, the first thing that we need to do, and it's actually an optional one, is the question: shall we base our API specifically on the logical data model, or will we go one level deeper towards the physical one, which will make the creation of APIs a bit more easier due to the fact that there is no inheritances, so no possibility of the need to support polymorphism in your APIs. And that's why I do suggest to go one step deeper into the physical model, where, for example, due to the fact that our party abstract object had the unique identifier, we have defined that as the business entity, and all other data with regard to the natural person, the professional details of a legal entity, and the organization details are created as different value objects linked to this party. So based on this model, to be honest, you actually have to, you are able to create both your resource and your API resource model. And we will do this based on the business entities and the value objects. So in general, the rule is a value object will always be part of a resource, and a business entity should always be considered as a resource or a sub-resource. And whether it's a resource or sub-resource depends on whether it's a strong business entity or a weak business entity. So our model here will be elaborated into the next resource model. So we have our subject area party. Within the party area, we have resource parties, which with this identifier. And from there, we can jump to the party preferences, the party addresses and pictures. And due to the fact that they are strong entities or strong business entities, they will probably also become an other path. However, the relations itself, it was only unique within the party, which means that the relation will always be a sub-resource, and we can go to the party/party ID/relation ID to retrieve a specific relation. If you go to the one specific endpoint and methods, for example, we have here the get of a specific party based on this ID. We will actually return every the business entity party and all the value objects and business entities that are linked with a composition. This is a bit black and white because there are a couple of other rules, but this will indeed bring us to deep dive or into too many information to bring in this session of 20 minutes. But I believe that if you start working like this, you will yourself be able to define or to find out what the extra rules are. So to wrap it up, how to design a functional qualitative API is actually start being really business oriented. Ownership is very important. So descent until the level of ownership is very clear and unambiguous. Second point is start with defining the domain model, qualify as a third one, qualify the concepts and the different relations. And this brings us to indeed a solid framework or method in designing APIs. And as I said, we do need to elaborate a bit further than what is presented here, but these high-level guidelines will really help you in defining the method that is suitable for your organization. So voila, 3 minutes over time, but I hope it was worth it for you guys.